3 delegates vote for an election, with each vote worth 4, 2 and 3 respectively. Design a circuit where the light is turned on only if a majority of votes are in favour. So what we have is 3 delegates being represented by X, Y and Z. And using our binary digits, we put all the possible permutations as follows. So 0, 0, 0, 0, 0, 1 and so on. So if a delegate votes in favour, the 0 will be a 1. So in the first case, the votes in favour are 0, and therefore the votes against are 4, 2 and 3, which is 9. And here the third delegate votes in favour, so his votes are worth 3, and therefore out of the 9, 6 votes are against. And here we have 0, 1, 0, so the second delegate votes in favour, and his votes are worth 2, so therefore 7 votes are against, and so on. And you may pause the video here and check if those numbers are correct. So therefore our function evaluates to 1 where the majority of votes are in favour. So here we have 0, 0, 0. And the next case is 5 votes in favour and 4 votes against. So the function should evaluate to 1. And in the next case, the majority of votes are against, so that's 0. And then we have the majority of votes for, so that will be 1, 1, and 1. Now if we consider the rows where the function evaluates to 1, so we have the inputs for this row being 0, 1, 1, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So we can write our Boolean expressions for each of these rows as the complement of x, y, z. So this states if the complement of x and y and z are all true, then the light switches on. And similarly we have x and the complement of y and z. Then we have x, y, and the complement of z, and then x and y and z. So again, if this second expression here is true, where x is 1, the complement of y, being the complement of 0, is 1, and z. So these literals must all be true for the light to switch on. And then we have x, y, and the complement of z to get all 1s for the light to switch on. And then we have x, y, z. So we put these switches in parallel because one of those expressions must be true for the light to switch on. So therefore our Boolean expression is the complement of x and y and z, or x and the complement of y and z, or x and y and the complement of z, or x and y and z. So this Boolean expression induces some function g, and now we want to verify if g is equivalent to f. So it should evaluate to 1 where the majority of votes are in favour. In other words, when either one of these expressions is true. So therefore for this first expression, we have x equals 0 and y equals 1 and z equals 1. And then we have an or. And similarly for the next expression, x equals 1 and y equals 0 and z equals 1. And for our third expression, x equals 1, and y equals 1, and z equals 0, or x equals 1, and y equals 1, and z equals 1. So therefore, we have 0, 1, 1, or 1, 0, 1, or 1, 1, 0, or 1, 1, 1. For g to evaluate the true. So if we scroll up, the inputs of our function g match the inputs of our function f that produce the majority of votes that are in favor. And therefore g is equivalent to f.